Okay, again, we're given questions and looking over questions. I mean, they really do look kind of challenging at this point. There's a trig question, there's a limit question, um, there's a polynomial question, that word problem, yada, yada, yada. You need to get started though. So again, you want to pick a confidence builder. And let's see what I could do here. I'm going to try number one first. Right? It might be a foolish thing to do because the word problem, I know a lot of students say word problem's going to kill me. And sometimes they do. Sometimes you read them, you don't even know what they're asking for. All right? Let's read. 2 missiles were fired at exactly 12 noon. One landed when the hands, the minute and hour, of the clock were between 3 p.m. and 4 p.m. All right, so I'm gonna make sure I understand what they're saying over here. That I'm gonna talk about missile one. It took off at 12 noon, but it landed between 3 and 4 p.m. And it says the minute hand and hour hand were exactly together. What does that mean? Let's take a look at that. Certainly 3 p.m. looks like this on my clock. Right, so I know the minute hand is going to be chasing that hour hand. It's a lot faster, by the way, but at some point it's going to catch up to it exactly. So the question is, how fast does the minute hand go? I'm going to say the minute hand does 1 rev every hour. And the hour hand does 1 rev every 12 hours. Well, I want to know at what time. So I'm going to say t equals some number of hours. So it's going to be greater than 0. I know it takes more than 0 to catch up to it, but it's certainly going to be less than 1. It's definitely going to catch up to it before it gets to 4 p.m. So I got to find out how this is going to catch up to it. So it's going to be a rate times time problem. So let's talk about the minute hand. Its rate is 1 rev per hour, but he's allowed to go for t. So it's going to be 1 times t. The hour hand is actually 1/4 of a rev head start. So I'm going to put 1/4 here. And how fast is he going? He's going 1/12. And he's given t. Same amount of time. Let me see if I can figure that out now. So what do you get over here? I would multiply both sides by 12. You get 12t. You get t. And this would be 3. So what do you get over here? 11t. Remember, t is in hours. 11t equals 3, or t equals 3/11ths of an hour. All right, so how long has the missile been in the air before it landed? Well, remember, he left at 12 noon, and now the time is between 3 and 4. So it's going to be 3 hours and 3/11ths. These are hours. That's for missile one. All right. What was the other question? Let's see. 2 missiles were fired exactly at 12 noon. One landed on the hand, spin hand, and hour hand and clock were together at 3 p.m. and 4 p.m. The other landed when the hands, minute and hour of the clock were together between 8 and 9 p.m. Well, that's another picture. So let me put down 8 and 9 p.m. Now, this is missile 2. So at 8, the minute hand's here, and the hour hand's over here somewhere, right? Well, it's really the same thing, except now the minute hand's going to take a lot longer to catch up to it. So again, the minute hand's going to catch up. You'll catch up to it, all right? Let's put this down. So it's going to be rate times time. Well, again, remember the minute hand's rate is still 1 times t. I don't need to put down 1, right? Let me erase that. Just like the other equation, right? T equals, well, the hour hand's got a head start, right? And what's the head start? Well, if you thought about it, 8, it's got 2/3 of a revolution of a head start. Let me make sure that's true. If you're at 8, 2/3, yeah, 20 minutes too, right? I mean, if I thought about it that way, that's 2/3. And then I get a head start. And what's his rate going to be? He's given a head start, by the way. His rate's still the same thing. It's going to be 1/12 of a t. Well, I'm going to multiply both sides by 12. I get 12t equals t. And 12 times 2/3 is 8. I got to continue to solve that. So 11t is equal to 8. So t is equal to 8/11. All right? Well, let's see. He left at 12 noon, right? And he landed between 8 and 9. So that's going to be 8 hours and 8/11. And this is total hours here. And that's for missile number 2. All right, let's look at the key, and let's see how we did. First missile, 3 and 3/11 of an hour. Second missile, 8 and 8/11 of an hour. All right? So that's not too bad. We did that one. A word problem, always kind of difficult. Now, certainly, if I were doing the next one, it looks pretty complicated, doesn't it? But I know it's a triangle. So I want to write some things down here. I'm going to start to erase this business over here. I'm at the whiteboard. And these are videos. You can always go back and look at them again. But it was not easy, though. I want to tell you that reading that sometimes is really hard to understand what you've read. And that happens to a lot of students. They read things, they have no idea what they've read. All right? So number 2, a little less reading. But they say it's a triangle. And I want to point out, if it's a triangle, I think this might be important. I know the angle A plus angle B plus angle C is 180 degrees. Or if you prefer to use radian, you can put down pi. All right? So I'm kind of looking at this, and I'm seeing the cosine B, cosine C, and I'm seeing the cosine of A. You know, I got a relationship between A, B, and C. This might seem strange to you, but I'm going to say B plus C is the same thing as 180 degrees minus A. And again, this could be a dead end. What I'm going to do is take the cosine of both sides. Let me write this down for you. The cosine of B plus C equals the cosine. And again, some students will look at this and say, this is really easy for me to do without all that writing. That's fine. Let me write this down for you. This can be cosine B, cosine C, minus sine B, sine C. All right, this is getting really complicated, huh? And what do you get on the other side? Well, let's see. You get cosine of 180, cosine A. The cosine 80 is minus 1, so you would get minus cosine A. And then you would get plus sine of 180. Well, that's 0, so I'm not going to put that down. Now, what was the question? Well, the question is, what's the cotangent B, cotangent C? Well, let me write this down now. Let me write down what they told me. All right, so they told me the cosine of B times the cosine of C is equal to the cosine of A. They did tell me that, right? So I'm kind of looking at my relationship I just wrote down over here, and I know they want to get this in the end. And I want to write this down now. So cosine of B, cosine of C, minus sine of B, sine of C, equals, well, minus cosine of A would be minus cosine of B cosine of C. I think I got something out of this thing. I'm seeing 2 cosine B cosine C would equal sine B sine C. Again, I still don't have that. So I'm going to try to divide both sides by sine B. And against a triangle problem, so this is all legit. Sine C. And this would be sine B sine C, right? So what do you get? 2 cosine B over sine B is cotangent B. And cosine of C over sine C is cotangent C. And the right side is 1. So therefore, the cotangent of B, cotangent of C, is 1/2. Is that what they asked for, though? I'm sorry, cotangent. Let's see if they asked for that. Cotangent B, cotangent C. Yeah, they did. So number 2, the answer would be 1/2. Let's take a look. 1/2. All right. So let me get my eraser out. And I'm going to start to erase this business over here. Again, I'm glad it was a triangle problem because it made it much easier. Now, again, let me probably mean by making it easier that the angles for a triangle have to be between 0 and 180. And that makes it easier for me to do the problem there, all right? All right, 3 I'm going to skip for the time being. I want to look at number 4, and although I don't think it's a good idea to cheat, they say don't use L'Hopital's rule, but let's say I were to use L'Hopital's rule. Let's say I were to use L'Hopital's rule. Let me write this down, limit. I'll erase this, by the way. I just want to say, what if I did? It looks like a pretty easy problem. Well, L'Hopital's rule applies because the limit at the top is 0 and the limit at the bottom is 0. It's an indeterminate form. So I'm going to do this. What would you get? You take the derivative at the top, which is n plus 1 x to the n, and the limit, I'm sorry, the derivative at the bottom is n x to the n minus 1. And you can do that limit. It's pretty easy. What do you do when x goes towards 1? The top is just n plus 1, and the bottom is just n. So at least I know my answer. But they said don't use L'Hopital's rule. So I got to erase this, but I do know the answer. Now, it'd be awful to say, oh, that's obvious. No, you got to put work down. So I got to look at this, and I'm going to look at this, and it's kind of reminding me of a geometric sum. Let me write this down for you. So I think I might be seeing something like this. 1 plus x squared plus, like x cubed plus yada, yada, yada up to x n. I'm going to call this Sn. I just want to remind you I'm going to see something here, at least hopefully I can see something. I'm going to multiply both sides by x, and you can get x times Sn. These are finite sums, by the way, so this is legit. So what are you going to get over here? X plus x squared plus x cubed plus yada, 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 and you're eventually going to get to x to n plus 1. I want to get this to look like what I got up there, and so I'm going to subtract. It's going to be x n plus 1. Again, I want to point out where I'm seeing that right over here. And then, a lot of stuff's going to just disappear in the problem when I do that subtraction. And I'm going to be left with what then? Minus 1. And what's that equal to? Well, it's equal to x Sn minus Sn, which is going to be Sn, the nth partial sum, x minus 1. All right, let me write this down for you now. x n plus 1 minus 1 over x minus 1 is really the same thing as Sn. So it's the same thing as 1 plus x squared plus x cubed plus yada, 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 plus xn. Now I realize some students will say, I knew that. Why would I go through all that work? You would not go through that work if you knew that. Now, of course, I want to write another one down. Right? I don't want to go through the work again. I got something down over here. What I want to write down is, I want to write down another one for you. I want to write, this one over here, which is 1 plus x squared plus x cubed. And I want to go to the one before that, which would be x to the n minus 1. Well, I'm not going to do the work again, but you could. X minus 1. The top would be xn minus 1. All right? What am I going to do now? Well, I guess I'll do a division. So I'll point out what I'm doing. I'm going to take this and divide it by this. And what would you get? X to the n plus 1 minus 1. These things will cancel off, by the way. And you get x to the n minus 1 equals, be very careful to write this down, 1 plus x squared plus x cubed plus yada, 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 up to x to the n. What goes on bottom? 1 plus x squared plus yada, 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 up to x n minus 1. Well, now I can write my work down. And what's my work going to be? I want to make sure I got the right thing down. Yep. Let's write this over here. So limit as x goes towards 1 of x to the n plus 1 minus 1 over x to the n minus 1 is identical to the limit as x goes to 1 of this nightmare, 1 plus x squared plus x cubed plus yada, yada, yada. And where do we stop? N. Because on bottom, 1 plus x squared plus yada, 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 all up to x to the n minus 1. Now, what are you going to do? Well, I don't have any division by 0, so I'm just going to plug in. And if you count them up, really not bad to count it up, by the way. I'll point out what I mean by that. There's going to be how many terms? 1, 2, 3, 4. There'd be n plus 1 ones. And write that down for you. So there's going to be n plus 1 times 1 on top. Each of those terms is equal to 1. There's n plus 1. Let's go to the bottom and count them up. All right? So you got 1. I'm plugging 1 in, by the way. This is another one. That's 2, 3. So you can get n of them. Let's write that down. What do you get over here? You're going to get n times 1. And what do you get over there? As expected, n plus 1 over n. We're getting it. All right? So again, we get it. I know I used L'Hopital's rule at first. And why did I do that? It was so easy to do. But they said don't use it, so I kind of erased it. And I kind of knew the answer going into it. But I put my work down. It's something to do with geometric sums, right? So let's take a look at what we've done so far. We've done 1. I've done number 2. I skipped 3 because it looked kind of nightmarish to me. And number 4. I did number 4, right? I want to look at number 5 now, all right? So, oh boy, this looks geometric again, doesn't it? So I'll put this one down. And let me just get my eraser out. And, certainly, you say, you're going to do the same work over and over again. Yeah, probably. All right, I'm starting to see a theme here. Like, maybe this looks geometric too. And I'm not even looking at the answer. Let me just get this all erased up here. And nice and neat. 3 I skipped, right? So let's take a look. Oh, I did it. I erase and all of a sudden it comes back. I don't know what's going on here. All right, let's write this down now. And I'll write it over here for you. So I'm gonna try to simplify this thing over here. And I'm gonna write this down again for you. It's really the same problem. It's not a limit though. So Sn would equal 1 plus a squared plus yada, 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 up to an. And then I'm going to say ASN is equal to, let's see what we get over here, A plus A squared plus A cubed plus yada, 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 up to an plus 1. All right, let's be real careful here. So I'm going to take the top one and subtract away the bottom one. And what are you going to get? 1 minus A Sn equals, my goal is to find out Sn, by the way, in a nice closed form, by the way, not this infinite thing. And what are you going to get? Well, upper minus lower, you would get 1 minus, again, all these things are going to disappear in the problem. So Sn, which is this thing over here, is just equal to this. All right, so this thing here, I just wrote it down. What do you get up here? 1 plus A, 1 plus A squared, 1 plus A4, yada, yada, yada. A lot of multiplication there, huh? 1 plus A 2 to the kth power. It's hard to write down, huh? Well, let's read the question now. I want to find a relationship between n and k, given that a is not 0 and a does not equal plus or minus 1. Well, I'm glad they're saying that, because if a were plus or minus 1, I'd have a division by 0. Not only that, if a were minus 1, this thing would be 0 according to that first factor. All right? So what I'm going to do over here, I'm going to write this down now. I'm going to write down 1 minus a to the n plus 1 is equal to, I'm going to clear the fraction, by the way, 1 minus a, 1 plus a, 1 plus a squared, and 1 plus a4, plus yada, 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 up to, I'm sorry, not plus, times, sorry about that. 1 plus a, that's an a, 2 to the kth power. Well, I'm noticing something nice about this. Look at this. That's really simple. What's going to be? 1 minus a squared. And then what do you get? 1 plus a squared. 1 plus a4 times yada, 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 times 1 plus a to the 2 to the kth power, right? Yeah, it's crazy looking, isn't it? Wow, looking at it again. What am I saying over here? 1 minus a to the n plus 1 equals, I'm seeing this guy. And what's that guy going to be? 1 minus a to the 4th power. Then when I get 1 plus a to the 4th, yada, 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 1 plus a 2 to the kth power. Well, I hope you start to realize I'm going to really see this until I get to the very last guy. So I'm going to say, you know what, I'm not going to keep doing this. I'm just going to write down where it's going to eventually end. And it's going to eventually end here. 1 minus a 2 to the kth power times 1 plus a 2 to the kth power. Let's write this down. 1 minus a n plus 1 equals, here comes the tough part. Gotta do that multiplication now, don't I? And basically just adding those exponents together, right? So it's going to be 1 minus a, I'm going to write this on the side for you, 2 to the k plus 2 to the k. Well, that's going to be 2 times 2 to the k, so it's going to really be 2 to the k plus 1. Now, what was their question? Find a relationship between n and k. Well, as far as I'm concerned, I have found a relationship between n and k. And let me write it down now. A to the n plus 1 is the same thing as A to the 2k plus 1. So I think I'm ready to write down the relationship between n and k. And what are you going to get? N, sorry about that, n plus 1, again, the bases are the same, so the exponents are the same, 2 to the k plus 1. And that's it. We got a relationship now. All right, mistakes happen. I always say that, I got an answer on it. Maybe I made a mistake somewhere. It's possible. And this is why, I always say, it's nice to have an answer key. And the answer keys are really nice to have. Again, the work we did over here, I hope you remember me doing that. And let's see if we got that relationship. Yeah, we did. N plus 1 equals 2 to the k plus 1. All right? And then make sure I wrote that down for you clearly, right over here. All right, again, this is me. It may not be you. Maybe what I thought was probably the worst looking problem was the best looking one to you. So again, just going through it, I don't think one was that bad, but people often get confused with clocks, myself included, by the way. 2 isn't that bad. 4 was okay. I kind of cheated a little bit in the beginning, if you recall. And there's nothing wrong with it. Just erase that, your track marks, so to speak, by the way. Can't hurt to think outside the box and then come back inside the box and do what they told you to do. And I think I did it right with 5 too. That was a little tough though, wasn't it? But I gotta be honest with you. If I look at this one over here, I just don't enjoy these type of problems. But a lot of people see these things as being incredibly easy problems. So I just want to cut to the chase. And I want to go to number 3 and show you the way I did it. And I just thought it was a lot of work. All right. So I want to point out that, and again, you may say, I do something completely different than you did. I don't like what you did, whatever. But what I did was I kind of multiplied it out. Not knowing what to do, all right? Not knowing what to do. And I just multiplied it out. And that doesn't seem too bad to me, like a cubed times b is a cubed b, minus a cubed c, b cubed c. You get the idea what I'm doing, right? And then minus ab cubed plus, I'm just doing them one at a time, right? Just looking at it. AC cubed minus BC cubed, all right? And I'm going to say that's relatively easy, but like most things in life, easy things could lead to really complicated things. So I thought that was really easy to do, by the way. And then the next thing I did was I rearranged the terms to look for things that I could understand how to do. And so what I did was I looked at terms that might behave well together, all right? So what I'm claiming over here, looking at it, I took... maybe I'll do this in red for you. I looked at this term and then looked for another term that might make it a little bit easier for me to factor. And I looked for another term with AB in it, and I saw it over here. And then I put them together. A cubed B minus AB cubed. And then I went to the next term, which was, the A cubed C. And I looked for, is there another AC in it? And I'm seeing that right over here. Let me see I got that right. No, I don't think I did that. Let me see what I did do. Let me erase this over here. Let me talk about the pairs I got down over here. Maybe you should look what I did, right? So I did A cubed B, AB cubed. The next pair I put down is A cubed C. Oh yeah, I put the C's together. I see that. They're looking for cubes now. All right, I did see that. And this one over here. Again, you can look for different combinations. And then last but not least, let me see if I got that right. A cubed C and B cubed C. And then A cubed. Yeah, I see that. Let me go for it. Let me get my eraser out. I'm seeing everything the guy did. I did it, by the way. I grouped the first 2 terms. I grouped the second 2 terms and the third 2 terms, and I factored each one separately. And the factor the first 2 terms in the rearrangement was AB, then A squared minus B squared. Yeah, that's not bad. Second one I factored a C out. That's A cubed minus B cubed. The third, it's a lot of work for me. Even it's confusing just to look at it. Factor out a C cubed and get A minus B. Yeah. And then what I do is I factored each term separately. I want to write that down for you, though, because sometimes, I always say, like, people look at math books and say, oh, you're missing a step over here. Sometimes when a step is missing, it's because it's obvious. But you would get AB, A minus B, A plus B. That's this guy right here. Then you'd get minus C. That's the difference of perfect cubes, though. So it's A minus B. And then you would get A squared plus AB plus B squared. And then you would get, last but not least, you get C cubed times A minus B. And what I do is I factor out A minus B from that. So each term I factor an A minus B out. All right, what do you be left off with? Well, in the first term, you'd be left off with AB times A plus B. On the second term, well, if I factor A minus B out, you'd be left with a C, then A squared plus AB plus B squared. You get this one over here. And the third term, you get C cubed. Now, granted, I'm going to say it's just so much work for me. And I'm not saying there's not a shortcut to this, but I'm here. And this gets crazy at this point. So one thing I do know, though, by doing this, I now know there's a root to the problem. And the root to this problem over here actually is A equals B, is a root to the problem. And this is often a trick to doing a problem. So if you know A equals B, you could make a substitution up here. So if A equals B, you could just make a substitution. And someone says, why would you do that? It actually makes it easy, all right? But here's the deal. You could make the substitution here as well if A equals B. And that's what I did. So I made that substitution. So I said if A equals B, this would be A squared. If A equals B, this would be A plus A. Now, I don't know what the C is, but A squared, A squared, A squared, and then you got C cubed over here. Now, if you add this all together, right, I'm just looking at that, I'm looking at this factor over here now, with the understanding that the root of the problem is A equals B. A must be equal to B, all right? And what am I doing over here? Just simplifying it. So what do you get? Well, let's take a look at this. This would give you 2A cubed. You see that there. This would give you minus 3A squared C and then C cubed. Let me get my eraser out. I'm going to have to erase this, doohickey information over here. And I'm at this line over here. Again, my trick here was to recognize that A equals B is a root of the problem. And that's why I made that substitution. Now I'm right over here. All right? And I'm looking at it, and I'm going to say that also has a nice easy root to it as well, where A would equal C. All right? Why is that? It would give you 0. So if A equals C, what would you get? You would get 2A cubed minus 3A cubed, if A is equal to C, plus A cubed. And this would definitely give you 0. So now A equals C. And what you could do now is basically go back and plug the C in. And you're going to get something pretty nice by doing that. It takes time and effort, though. And this is what I find really tedious about this. Let me erase this over here. All right, so by inspection, I noticed that A equals C, plugged it in, got the 0. And that means A minus C is a factor. All right, so let me point this out. I noticed in the beginning that A equals B. Then I noticed A equals C. So what do I know? No, I know there's two factors, A minus B and A minus C. All right, I know there's two factors over there. And what you could do, if you want to, you could do a long division if you want. It's not a bad idea to do. And I really mean that. It's not a bad idea to do. For example, over here, I could divide this easily now by A minus C. And if you did that, you'd get this. And finally, what we know A minus B is a factor. We know A minus C is a factor. And when I did the long division, let me see. I got this over here. I'm sorry. 2A plus C. I got this. We'll talk about the next line later. A minus C. Okay. Let's talk about it in the next line they're giving me down over here. By the way, there's nothing wrong with this line over here. This is fine. What I want to claim over here is that, 2A, right? 2A. And I hope you realize that 2A is A plus A, and A is B, and that's why I wrote this over here. You don't have to do that, by the way. And again, I know A is equal to B, So that's why I wrote this over here. But they're really the same. They're all the same. All right. So I'm going to claim. I think I did okay with that. You may want to expand these guys to show that this is okay. I wouldn't, if I were on a competitive exam, I wouldn't be expanding anything. I'd be thankful I got to the end of it. I really mean that. And anyway, the clock's ticking for most people. So I personally think 3 was the worst problem. All right. You may disagree. All right. This is why on a competitive exam is you really need to start targeting problems that you can do quickly. So in hindsight, I'm going to probably say that for me, 1 was probably the easiest one to do, and then followed by 2. I'm going to say 4 was pretty simple to do once I figured out some of the geometric. This gave me a hint on doing number 5, by the way, after doing number 4. Kind of accessible my confidence up. But I'll be honest with you, this one took me time and effort to get through. All right? Now, I'm always saying to you guys, you can always reach out to me if you want to, provided I'm not overwhelmed with email. My email address is Bannon, that's B as in boy, @NNON.US. And again, if you reach out to me and I'm not overwhelmed, I'll get back to you. All right? But again, thanks for paying attention. Again, I want to remind you the PDF document has not been published. It will be published though. Right now, the only people who have access to this document are the people participating in the prison mathematics project. All right? So they're the only people that have access to it. But here's the deal. At some point, it will be published. The reason it's not published is that a lot of these problems have not been carefully looked at yet. I mean, it might be me looking at it, but I'm the only eyes on this. And I really appreciate you paying attention to this, and I do wish you a good deal of luck in solving problems. Thank you.